Hello students, I hope that you are good, well and fine. In today's session, we will be covering NCERT exercise 10.3, okay, Vector Algebra, of chapter Vector Algebra, chapter 10. The first question of this exercise says, find the angle between two vectors A and B with magnitudes √3 and 2 respectively, having dot product is equals to √6. So everything is given to you. Just apply your formula. So your formula says that dot product of A and B is equals to product of their magnitude and the the product of the magnitude going to be multiplied with cos theta, where theta will be the angle between A and B. Everything is given to you. This means cos theta will be √6 divided by √3 times 2. This means cos theta will be 1 by √2. This means theta will be pi by 4. Okay, so angle between the given two vectors is pi by 4. Okay, now question 2. Find the angle between the vectors, these two vectors. The same approach we will be applying. So A vector and B vector. Magnitude of A will be √40. Magnitude of B will be √40. Having same magnitude. Dot product will be what? As you can see. Multiply the corresponding components. You will get 1 multiply 3 minus 2 multiply with minus 2 and 3 multiply with 1. So this means 3 plus 4 plus 3 means 10. Dot product will be 10. You know this formula. This means cos theta will be 10 by 14. This means theta will be cos inverse 5 by 7. So your required angle will be cos theta inverse 5. Sorry, theta will be cos inverse 5 by 7. Now problem 3. Find the projection of this vector I hat minus j hat on the other vector which is I hat plus j hat. Okay. So whenever you have a vector, okay, and you have to find the projection of a vector on the other vector, you will have to do what? Just nothing but first of all find the dot product of both of them and then divide by the second vector magnitude. Here second vector is, so this means first of all dot product will be what? Very easy to find. Multiply the corresponding components you will and then add up, you will get your dot product and divide by the second vector magnitude. As you can see here, you will have 1 by √2 multiply with 1 minus 1 means 0. Okay, so your projection vector will be just 0 vector. Okay, now fourth problem. Fourth problem says that find the projection of vector, this vector on the other vector. Okay, the same approach we will be applying. That first of all find the dot product. Dot product will be 1 multiply 7 plus 3 multiply minus 1 plus 7 multiply 8. As you can see, this will be, numerator will be 60. Denominator will be the magnitude of this second vector b. This means √114. So your projection vector will be, okay, projection of vector of A on vector B will be this. So, magnitude will be this and direction can be find out by using visual representation of these two vectors and how we are going to project it. Okay. Now fifth problem. Show that each of the given three vectors is a unit vector. Okay. Also show that they are mutually perpendicular to each other. So what you have to show? That the given three vectors all are unit vectors and they are mutually perpendicular. This means first of all find their magnitudes. So magnitudes, as you can see, the magnitude for A will be 1 B will be 1, C will be 1. This means unit vectors. Whenever we have a vector having magnitude equals to unity or 1, this means that vector must be a unit vector. Now, in order to find the perpendicularity, we have to find dot product, which means A dot B, A dot C and B dot C. Okay. If their dot product is coming out to be 0, this means they are perpendicular to each other. This means A dot B, as you can see, 0. B dot C, 0. C dot A, 0. This means they are mutually perpendicular to each other. Okay. I hope it is. Now, sixth problem. Find magnitude of A and magnitude of B. If you have already given that their dot, thus dot product of sum of these two vectors A and B and difference of these two vectors is going to be 8. And also another relation that magnitude of A vector is equal to 8 times magnitude of B vector. So how we are going to find? Quite simple. Distribute this thing or expand this thing. You will get what? You will have A dot A minus A dot B plus B dot A minus B dot B. Both of these two middle terms going to be cancel each other. This will be square of magnitude of A. This will be square of magnitude of B. You know magnitude of A can be rewritten as 8 times magnitude of B. This means 64 times magnitude of B whole square minus magnitude of B whole square. This will be 63 times magnitude of B square. Rearrange your term. You will get your magnitude as root of 8 by 60. As magnitude is as you can see, magnitude must always be positive. Okay. Clear? This means after simplifying, if you want to simplify things, you will have magnitude of B. The numerator will be 2 root 2 divided by denominator will be 3 root 7. And from this, you can directly find out your magnitude of A, which will be 8 times of this. This means 16 root 2 divided by 3 root 7. Okay. Easy to find. Now, seventh problem. Evaluate this product. Just simple evaluation. So, 3A product with 2A, 3A dot product with 7B, minus 5B product with 2A, minus 5B dot product with 7B. Just simplify your things. This will be 6. A dot product with A, 21 A dot product with B, 10 A dot product with B, 35 B dot product with B. Now, whenever a vector dot product with itself, the output will be always the square of the magnitude of that vector. So this means 6 times square of magnitude of A. Here 35 times square of magnitude of B. And you can easily simplify them. The answer, the output will be, the difference will be 11 dot product of A times B. So you will have this as your simplified version. Okay. Clear? Now, eighth problem. Find the magnitude of two vectors A and B having the same magnitude. So the magnitude of A and magnitude of B both must be same, such that the angle between two of them is 60 degree and the angle between two of the given vectors is 60 degree. Okay. And their scalar product is half. So you can easily find your magnitude. How? You have the formula. What formula I am talking about? I am talking about A dot B is equals to product of magnitude of two vectors and with product with cos theta. As you can see, dot product, you know, half. Magnitude of A and magnitude of B both are the same. This means magnitude of A, you can write. Theta is 60, this means cos 60. Now, half, cos 60 is just half. So, you will have just nothing but square of magnitude of A is equals to 1. This means magnitude of A must be 1. This means if magnitude of A is 1, then magnitude of B will also going to be. Okay? I hope it is clear. Now, ninth problem. Find magnitude of X if a unit vector A. So, A is our what? Unit vector. That means magnitude of A will be 1. So, one condition is already given, that magnitude of A is 1. And this dot product is given to you 12. So, simplify this to get your X magnitude. So, let's see. X multiplying with it, X itself, dot product. X dot product A dot product X, A dot product A. This term will going to be square of magnitude X, and this going to be square of magnitude of A. The middle two terms cancel each other out. You will have magnitude of X square minus magnitude of A square is equals to 12. Okay. Sorry, square of magnitude of X is square of magnitude of A is equals to. You know the magnitude of A is 1. This means 1 square will be just 1. So you can rewrite it as what? Square of magnitude of X is equals to 13. This gives you magnitude of X is equals to root 13. Magnitude of X will be root 13. Clear? 10th problem. If a vector A and vector B and vector C are satisfying this condition that vector A plus lambda times vector B, this output vector is perpendicular to vector C, then find your lambda value. Okay. So first of all, find this thing, vector A plus lambda times vector B. After finding, you will have to do what? The dot product between this resulting vector and this C vector and put it equals to 0 because of the perpendicularity. A, B, C vector is given. A plus lambda B vector will be 2 minus lambda I hat plus 2 lambda J hat plus 3 plus lambda A hat. This and this vector dot product will be 0 because of the perpendicularity. This means your A plus lambda B vector is this and C vector is this. Now apply your distributive property. You will have 6 minus 3 lambda plus 2 lambda is equals to 0. This means minus lambda plus 8 is equals to 0. This means lambda will be 8. So hence the required value of lambda is 8. Okay. Very easy. Clear? Okay. Now 11th problem. Show that magnitude of A multiply with vector B plus magnitude of B multiply with vector A is perpendicular to magnitude of A multiply with vector B minus magnitude of B multiply with vector A for any two non-zero vectors A and B. Okay. So this and these two vectors are perpendicular. This means their dot product, I have to show that it equals to 0. So find the dot product. So dot product of these two vectors can be rewritten as square of magnitude of A multiply with dot product of B with B itself minus magnitude of A multiply with magnitude of A multiply with dot product of B and A plus magnitude of B multiply with magnitude of A multiply with dot product of AB minus square of magnitude of B multiply with dot product of A with A itself. This gives you that these two middle terms will be cancelling each other. You will only left with this, and as you can see, square of magnitude of A multiply square of magnitude of B is same as square of magnitude of B multiply with square of magnitude of A, and you are doing what? The subtraction. This means you will have 0. Okay, so means perpendicular to each other. Okay. Now 12th problem. If dot product of A with itself is equals to 0 and dot product of A and B is also 0, then what can be concluded about the vector B? So if this is given, A with A itself is equals to 0. So, and you know the dot product is 0. This means what? This means you will have the 90-degree angle, but A with itself cannot make 90-degree angle. Angle A cannot make 90-degree angle. So angle is 0. Clearly it is given that angle is 0. So this means that square of magnitude of A is equals to 0. This means this can only be happen when A is our 0 vector. Okay, A is our 0 vector. So this is already given to you that A must be 0 vector because of this. Hence, B can be any vector. We can conclude that B can be any vector. As A is your 0 vector and 0 vector multiply with any vector gives you 0 out. Okay, 0 as your scalar. Clear? So that's why B can be any vector. Now 13th problem. 13th problem says you are having 3 vectors and all the 3 vectors are unit vectors, such that unit vector means you already know them, that their magnitude going to be 1. So such that the vector A plus vector B plus vector C is equals to 0. Then you have to find A dot B plus B dot C plus C dot A. Okay. How you are going to find? Quite simple. Let's see. So as it is already given that all the 3 vectors given to you are unit vectors. This means magnitude of A, B, C all are equals to 0. This is already given. So A plus B plus C is equals to 0. This means what? Square both sides. Okay, this is given to you. Yes, so squaring both sides. Okay, you will have A plus B plus C. A plus B plus C dot product with A plus B plus C. Yes, okay. This gives you square of magnitude of A plus square of magnitude of B plus square of magnitude of C plus 2 times dot product of AB plus BC plus CA is equals to 0. What we did? Square. This is 1, this is 1, this is 1. So 3 plus 2 dot product of AB plus BC plus CA. Rearrange your terms. Okay. You will have dot product of AB plus dot product of BC plus dot product of CA is going to be minus 3 by 2. Okay, minus 3 by 2. Now 14th problem. If either vector A or B is 0, then your dot product is 0. But the converse need not to be true. This means if you are given that dot product is 0, then it cannot happen, or it will not tell you about general case that in generally A is going to be 0 or B is going to be 0. For example, this means you have to give a counter example. So consider A and B as following. Find the dot product. The dot product will be what? 6 plus 12 minus 18, which is going to be 0. But if you consider magnitude of A, you will have root 29, which is non-zero, where A is non-zero vector. And magnitude of B is equals to root 54. This means still non-zero vector. Okay. So hence you have 2 non-zero vectors, but their dot product is 0. So whenever you are given that A vector or B vector is a 0 vector, then you can directly say about the dot product. That dot product going to be 0. But if you are given that dot product is 0, then you cannot say that either of them are going to be 0. Okay. Now 15th problem. If the vertices ABC of a triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2, respectively. Okay. Then find your angle ABC. Okay, then find your angle ABC. Where angle ABC is the angle between the vectors BA and BC. Okay, so first of all, you have to find your vectors BA and BC, and then apply your concept of dot product to get to know about your angle between these two vectors. So first of all, as coordinates already given to you, you can directly find your vector. Okay, BA and BC. So BA will be what? Coordinates of A minus the corresponding coordinates to B. This means -1 I hat, 0 -2 j hat, 0 -3 k hat. This gives you 2 I hat plus 2 j hat plus 3 k hat for BA vector. Now for BC, 0 -1, yes, 0 minus, sorry, okay, 0, sorry, BC vector I have to find. So this means 0 minus 1, 1 minus 0 j hat, 2 minus 0 k hat. This gives you I hat plus j hat plus 2 k hat. Now dot product them, you will get what? The dot product will be this, which means a scalar product, which means the output must be some scalar. This means to multiply corresponding component with the corresponding component, you will have 2 multiply 1, 2 multiply 1, 3 multiply 2. This means 4 plus 6 gives you 10. So 10. Dot product, you are having dot product. You are having your two vectors. Now you can easily find your magnitude for BA vector and BC vector. The magnitude for BA vector is √17 and for BC vector is √6. As you can follow that. Now you have your formula that vector BA dot product with vector BC is equals to product of their magnitude multiply with cos theta, where theta is angle between BA and BC vector, where theta we are representing it by angle ABC. Okay, you know the dot product is 10, you know their magnitude, so √17 and √6, cos theta, which is angle ABC. This means cos angle ABC is equals to 10 divided by √17 product with √16. This means angle ABC is equals to cos inverse 10 divided by 1 root of 102. Okay, I hope it is clear to you. Very easy to find things. Now 16th problem. Show that the points are collinear. So you have to show that the 3 points given to you collinear to each other. So how you are going to show that? So very easy. First of all, find the vectors AB, BC and AC. So AB vector will be I hat plus 4j hat minus 4k hat. BC will be I hat plus 4j hat minus 4k hat. AC will be 2I hat plus 8j hat minus 8k hat. Whenever you have collinear vectors, this means you can write them as what? A vector is equals to scalar times of other vector. Okay, if you are successful to making that form, this gives you the collinearity. Okay, clear? Now, as you can see, the absolute value or the magnitude for AB will be √33, BC will be √33, AC will be 2 √30. Okay, this gives you that magnitude of AC is equals to magnitude of AB plus magnitude of BC. Clear? Okay. And another thing you have to see that AB vector and BC vector both are the same vectors, as you can see. Yes? Okay. So both are the same vector. Now, AC vector is just 2 times of AB and BC. So AB vector and BC vector both are the same vector, and AC vector will be the 2 times of AB vector and AC vector will be the 2 times of BC vector. So we are successful to write a vector is equals to some scalar times of another vector, which shows that these vector must be collinear, or these vertices, or sorry, these points will be collinear. Okay, I hope now it is clear to you. So they are collinear. Okay, now show that the given 3 vectors form the vertices of a right angle triangle. So in order to form a right angle triangle vertices, okay, what you have to show? Very easy. Let it satisfy somewhere the what? Your Pythagoras thing. Okay, so OA vector will be the I am finding the position vectors respectively for A, B, C points, A point, B point, okay, C point. So OA vector is given this, OB vector will be this, OC vector will be this. Now these represent AB vector, BC vector and AC vector represent the sides of triangle ABC. So OA vector, OB vector, OC vector already given. This gives you AB vector as, using your properties and triangle law, you will have minus I hat minus 2j hat minus k hat. BC vector will be 2I hat minus j hat plus k hat. AC vector will be minus I hat plus 3j hat plus 5k hat. The magnitude for AB will be root 41. Magnitude for BC will be root 6. Magnitude for AC will be root 35. If you square magnitude of BC and add it to the square of magnitude of AC, you will get 41, which is square of magnitude of AB. This shows that AB will be your hypotenuse, B and C will be your other two sides of right angle triangle. Okay, so this shows that indeed you are getting a right angle triangle. Clear? Now, the last problem of this 10.3 exam exercise. Okay, so if A, this vector A is a non-zero vector of magnitude A and lambda be a non-zero scalar, then lambda A is a unit vector if. Quite simple. So lambda A is a unit vector if. Okay, so only when you know that the magnitude of lambda A is equals to 1, the unit vector means this thing. Okay, this can be rewritten as lambda A, sorry, absolute value of A multiply with magnitude of A is equals to 1. This means magnitude of A must be 1 by lambda A, where 1 by modulus of lambda. This means lambda cannot be 0. This means lambda not equals to 0. This gives you that your A vector, as you know, the magnitude of A is same as A. This means A will be 1 by absolute value of lambda. So this can be only possible when you have A is equals to 1 by lambda. So A is equals to 1 by lambda means D option will be a correct option. Okay. So this is it for exercise, NCERT exercise 10.3. For now, we have to stop it here as time is also running out. So thank you all. We will be back with more exercise and concept from this chapter, Vector Algebra, chapter 10. So again, thank you.